Often when we deal with graphs, we are required to find a range of a given graph. In this case, we are asked to find the range of f, which is an exponential graph. Of course, the question is, how do we write the range of a given graph? And this takes us back to the understanding of the intervals in the Cartesian plane, whether it's in the horizontal x-axis or the vertical y-axis, and we need to know how to write that interval correctly in order to represent the range of the graph. In the same way, we are required to write the range of g. We need to be able to represent this correctly. This is, of course, referring to the possible y values for this particular graph. And we need to understand how do we write that correctly, and that needs us to understand inequalities. That needs us to understand how to represent the interval in terms of set notation and interval notation. All right, to write the range of a graph, we of course have to be able to write the interval in the y-axis, and in this case we're looking at the y-axis as the vertical number line. And you can see that at point A here, this is 0, and at this point we've got an unshaded circle, which means this point would not be included. So if we're looking at the y values, you'll see that it's all the y values, so y is an element of real numbers, but we do not include a, and therefore we'll say y is not equal to 0. Now if we look at the numbers above 0, those are the numbers that are positive, so we'll then say all these values are greater than 0. So y is greater than 0, as you can see, and you can also write it, y is an element starting from 0, and remember it's unshaded, and that is why we've got a curly bracket here, and it's starting from 0 or just above 0 up to infinity, and we do not include infinity, as we already know. And of course we can look at the numbers that are below the number 0, and these are the numbers that are negative, so we say y is less than 0. So all the y values on this side are less than 0, and we can write it as y is an element of from minus infinity, open bracket, up to 0, and of course we do not include 0, as we have seen already. Alright, we can also look at an interval between two numbers, two values of y in this case. We've got minus 3 as well as 5, and we're looking at the interval or the values of y between minus 3 and 5. And you can see that minus 3 is not included, it's an open circle or it's an unshaded circle. And you can see that 5 is included because we've got a shaded circle here. So we write this as minus 3 is less than y, and of course it's not less or equal to because it's an unshaded circle, and y is less or equal to 5, and you can see that we've got 5 included here because it is a shaded circle, as you can see. We can write it also in set notation and write interval notation, and write it as y is an element of an open bracket because minus 3 is not included, and of course we close the bracket because we've got a square bracket because 5 is included in the solution. So if you remember these things, it will become easy when you want to represent the range of any graph. Remember, this applies across graphs, and that is why I'm taking time to discuss the Cartesian plane and how do we deal with the different cases, especially to represent the intervals, because that seems to be the problem that people have in terms of writing down the range, or when the question asks where the graph is increasing and so on. Once you know how to write the intervals, it's going to become easy to answer a lot of questions when you deal with functions. Alright, now we have the basics. We can answer the question now that was asked. The question was saying write down the range of f, and of course we know that it's all the possible y values for this particular graph. Now remember that this line here is an asymptote, so this graph technically does not touch this line. Although it would seem here it touches the line, it actually comes close to touching the line, but it does not touch the line. So the values of y for this particular graph start just after this particular line, which is an asymptote, and it goes up to infinity. So we can write this, and we must remember that this particular value of minus 3 is not included, and therefore we have an open circle here, and we can see the line going up to show that these are all the possible y values for this particular graph. So we'll therefore write y is greater than minus 3, and it's not greater or equal to, it's greater because it is not, minus 3 is not included. Or we can write it as y is an element of, open bracket, from minus 3 up to infinity, and see that it's an open bracket because it's not included, and also here it's an open bracket because it's not included. Now you must remember these two ways of writing, or this notation, you do not have to write both. You can write one, whichever that you find easy to you or which you are comfortable with. You can write one of the two. Of course, I prefer the simple one because I don't have to remember what brackets do I have to use and so on. But your preference is important, and what you understand better because maybe you've used it more is more important than just what I prefer myself. We can also now answer the question about the range of G, and we have the interval that is required. You can see that this is the maximum value of the graph, the turning point, and at this the maximum value here is 3. So the possible values of k, of y for this graph are all below 3, starting from 3. So the values here cannot be part of the graph because you cannot draw a horizontal line that will cut the graph if ever you are at this point. So we write therefore y is less or equal to 3, because remember that this part is included. It's not like the other case that we discussed where there was an asymptote. This is the value of the graph, which is the the y value of the turning point, and therefore it is included. Therefore we write y is less or equal to 3, hence it is shaded. But we can also write it as y is an element of, we start from minus infinity from the bottom and we go up to 3, and look at the square bracket to show that 3 is included as part of the solution. Once you are able to write this, it's a very good start, and with the domain and the range, which is very common when dealing with graphs, it will become quite easy to understand and to use these intervals. But remember, the intervals are not limited to the domain and the range. You've got a number of other questions that will require you to understand the intervals, and that is why it's important that you can make sense on how to represent them and what do they mean. And once you are able to do that, you will see it will become easy to start to answer questions that were difficult with graphs.